So this video is all about energy transfers and how to reduce unwanted energy transfers with a specific focus on in the home. So it's a truth universally acknowledged, to quote Pride and Prejudice, that in all real life energy transfers, some energy will be dissipated to an unwanted form. Now, what does that sentence mean? So in all real life energy transfers, some energy is dissipated, and the word dissipated is simply quite a posh way of saying wasted or spread out. So it's a good word to use in your exams to show you know what you're talking about. And to an unwanted form, so a form that we don't want. Now, usually this form is heat. It's not always. For example, if I'm boiling a kettle, then heat is wanted. The unwanted form then might be sound. But generally, the dissipated energy will be as heat, and heat will always occur in every energy transfer, because in all real life energy transfers, there's always less than 100% efficiency. So we always waste some energy, and that's what the word dissipated means. We waste, and that energy usually spreads out to the surroundings. So think about, for example, when you're charging your mobile phone, you don't want it to get warm, but it does. It's not a useful thing, but we're actually dissipating energy there as heat, and it's spreading out to the surroundings of the phone, and then it will spread out to the surroundings around that. Now, there are some general things we can do to reduce energy losses, and you need to know about them for two main systems. Mechanical systems, that's systems with moving parts. And then electrical systems, which are systems that use electricity. For mechanical systems, anything with a moving part, the way we reduce an energy loss generally is to lubricate. So we lubricate the moving parts, and this reduces friction. And if we reduce friction, we reduce the work done against friction, and therefore we reduce energy losses due to friction. The most common examples for this that you might think about are, for example, a bike. If you ride a bike, you'll know that the gears are full of grease. If you ever catch your leg against it, you'll get like a black mark on your leg. But the grease is there for a reason. It's there to lubricate the gears, so it reduces friction and means you're losing less energy. So if you're ever asked in an exam about how do we reduce energy losses in mechanical or moving systems, lubricate to reduce friction is always your first port of call. For electrical systems, which we'll come on to more in later topics, we use low resistance wires. And these are wires that don't heat up so much. Use low resistance wires. And therefore we lose less energy due to heat. So they're already used in most systems, but that's one way to remember it. Now, the main one for today is mechanical systems, if you are looking at energy in topic 3 or 8, I think it is, but this will come up more later on in the GCSE. Now, one of the main areas of thinking about energy losses are in the home, and energy is transferred in 3 main ways in the home, which can then cause losses. It's transferred via conduction, convection and radiation. Now, you don't need to have a massive knowledge of these, but because you should remember them from Key Stage 3, but just some kind of like key points. Conduction happens in solids, and it's often said through direct contact. So things have to be touching for conduction to happen. And conduction is when you have, for example, the particles in a solid that are arranged like this. They're in nice regular rows. If you heat up one end of the solid, these particles will start to vibrate and jiggle around more, and they'll pass those vibrations along the solid. So it will transfer the energy along the solid, but generally happens in solids with direct contact. Then we have convection. Convection doesn't happen so much in solids, it happens mainly in gases and liquids. And it happens because hotter gases and liquids are less dense. And therefore rise. So you've probably heard the phrase hot air rises. It does. It gets less dense and therefore it rises up. And what then happens is that cold air can swoop in to fill in the gap that's been left, and it causes convection currents. So you often see it drawn in this kind of manner. So if you have, for example, a heat source here, this air will heat up and will rise, and then some cold air will swoop in to take its place and then heat up and rise. And we set up convection currents, and that's how radiators work. They set up convection currents in your house to try and heat your house up. Then our final one, we have radiation, and this is basically another word for AKA infrared. So it's an EM radiation, i.e. it's a wave, and it can travel through a vacuum. And it spreads out in all directions. It's basically like, you can't really, well, you can stop it, you can reduce it, but you can't, it just kind of happens. That's a terrible explanation, I apologise. Just to add to this, convection, because things virtually generally rise, often we think about convection going upwards, whereas radiation can go in all directions, and conduction can go in all directions, but it has to be through a solid, through direct contact. So in a house, we get a lot of energy losses. You can always tell if you've got a poorly insulated house if you look at the roof in winter when it's been snowing. If there is no snow on the roof, it will be poorly insulated because the heat has got from the house to the roof to melt the snow. And there's different ways that heat can escape. It can escape via conduction. For example, conduction might be through the walls, or through the windows, or through the roof, or through the floors, anything solid. So if it's going through a solid object, it's going through conduction. Convection, it's when things rise. It's usually through the loft, energy losses, so upwards. So it'll lose energy due to convection up to the roof, and then when it hits the roof, then it'll go through conduction. So I'm going to write through loft there. And then radiation can basically be through anything. That's what I was talking about before when I was trying to explain the problems with that. Radiation can get through anything, but the main one we're going to look at today is conduction through walls, windows, roofs and floors. But we'll look at that in more detail in a moment. For this section, just want to think about how we can try and reduce energy losses in the home. So there's some really common things. If you just look around your house now, there's some stuff that you will take for granted. So for example, in your roof, you'll have insulation. So we insulate the roof to try and reduce energy losses. You'll also have in your walls, you might have something called cavity wall insulation. And that's where you have, so whenever you build a house, there's always two walls. So the wall that you are seeing inside your house is the inside wall, then there's a gap, and then there's another wall. So these are my bricks. Now, it might just have air in the middle. Air's a really good insulator, so this actually stops a lot of the energy getting out through conduction, because you have conduction through the solid, then it hits a gap of air and can't get through, and then goes through the next solid. But sometimes it's filled with like a foamy stuff, and that's cavity wall insulation. It's a better insulator than air. So often people will try and improve their insulation. They'll drill a hole into the wall and they'll fill it with this expanding foam. Other things that help similar to this is double glazing. So double glazing has two main reasons. One, it reduces energy losses, but it also reduces the amount of sound that can get through into your house. If you're living on a main road, you'll definitely have double, maybe even triple glazing. And double glazing is that you have two panes of glass with a near vacuum in between them, and that near vacuum stops the heat being able to conduct or convect, because if there's no particles, neither of those can happen. Some really common things that we have: curtains. And also carpets. So soft furnishings aren't there for random reasons. They're there to try and keep in the heat. So we didn't used to have carpets in all houses. It was too expensive. But as people have been able to afford it, carpets are much more common. Curtains, in the olden days, they used to have tapestries on the walls. You might have draft excluders. That's you'll see them often on a letterbox, the kind of like fur, like brush kind of stuff. Or you might have like a homemade draft excluder that you put in front of a door to try and stop the draft getting through. All things that help us try to reduce those energy losses. Other things include putting silver paper behind radiators. That works, it reflects the heat back. Having really good sealants around your windows. That's the same idea as the draft excluders, around your doors. Just everything that you kind of know of to keep the heat in, as your mum or dad might say. So I said we were going to concentrate mainly on conduction and about how we can decrease this energy loss through the walls, through the windows, through the roof, through the floor. And examples are here cavity wall insulation and double glazing. And they work for a reason. They work because they reduce the thermal conductivity of your house. Now, thermal conductivity is a measure of how well a material conducts heat. Now, if I look at this list of materials, I've got here copper, iron, wood and plastic. And copper and iron, I would generally say, are good conductors. That means that heat can easily travel through them. And wood and plastic, I would say, are good insulators, which means they stop heat travelling through them. And they both have their pros and cons, depending on the situation. Now, thermal conductivity is how well a material conducts heat. So good conductors have a better thermal conductivity than bad conductors, which are also known as good insulators. And if I drew an arrow here, I could label this saying increasing thermal. My phone's just fallen off. I'm just going to put it back, hopefully the same way, so I don't have to start the whole thing again. Fingers crossed. There we go. So increasing thermal conductivity. I'm really wary now of making my, it's a very homemade setup to try and keep my phone suspended above the page. So we're increasing our thermal conductivity as we go from the good insulators to the good conductors. Plastic is a better insulator and a worse conductor than wood, and iron is a good conductor but not as good as copper, so it goes up in this order. Now, if we want to decrease the rate of heat transfer, i.e. decrease the rate of cooling, so if it's the middle of winter and you've got a really warm house and you want to keep it warm and not let it get cold, there's two things you can do, okay? You can increase the thickness of your walls, or you can decrease the thermal conductivity of your walls. You want to be made of materials that don't conduct heat well. You want to have good insulators, you want to have wood and plastic and brick and vacuums and air. So you can either decrease the thermal conductivity, make them less good conductors, make them better insulators. I'll put that in brackets, better insulator. And you can also increase the thickness of the wall because that will make it a better insulator. It'll be harder for the heat to get through. So they're the main kind of highlights or headlines for decreasing unwanted energy losses, especially for Edexcel GCSE, but generally at GCSE level. Hopefully that was helpful, even with the slight technical hitch in the middle there. Thank you.